Hi, in this module I will discuss strain transformation using Moore's circle. We have learned that the strain at a point in nth direction can be written as epsilon nn equal to epsilon xx plus epsilon yy by 2 plus epsilon xx minus epsilon yy by 2 cos 2 theta plus gamma xy by 2 sin 2 theta. Therefore, I can write epsilon nn minus epsilon xx plus epsilon yy divided by 2 equal to epsilon xx minus epsilon yy by 2 cos 2 theta plus gamma xy by 2 sin 2 theta. We have also learned that the shear strain gamma nt can be written as minus epsilon xx minus epsilon yy by 2 plus gamma sin 2 theta plus gamma xy by 2 cos 2 theta. Here also gamma nt divided by 2. Now squaring this equation and also squaring this equation and adding these two equations, we get epsilon nn minus epsilon xx plus epsilon yy by 2 whole square plus gamma nt by 2 whole square is equal to. Now if you look at the right hand side of equation 1, this is a, this is b, so it is a plus b whole square, and this is minus a plus b whole square. So in the first term we have exx minus ey by 2 as common, and cos square theta plus sin square theta will become 1. So we will get epsilon xx minus epsilon yy by 2 whole square plus, in the second term gamma xy by 2 will come common, and cos square theta plus sin square theta will again become 1. So we get gamma xy by 2 whole square. From equation number 1 plus 2ab and from equation 2 minus 2ab will cancel each other. So we get this equation if we compare this equation with the equation of a circle, which is x minus a whole square plus y minus b whole square is equal to r square. We can say that instead of x we have epsilon nn, instead of y we have gamma nt by 2, instead of a we have this term, and instead of b we have 0, and the radius is given by the under root of this entire term. So I can write instead of x we have epsilon nn, that is normal strain in nth direction. Instead of y we have gamma nt by 2. In place of a we have epsilon xx plus epsilon yy by 2. Instead of b we have 0, and the radius of the Mohr circle is given by under root of epsilon xx minus epsilon yy by 2 whole square plus gamma xy by 2 whole square. The center of Mohr circle is given by a comma b equal to epsilon xx plus epsilon yy whole divided by 2 comma 0. So the y coordinate of Mohr circle is 0. So we have learned that the strain transformation equation at a point can be represented using a circle, which we call as Mohr's circle. Now each point on Mohr circle represents a particular direction passing through point A. Consider a differential element at point A. This is point A. At point A, x direction is like this, y direction is like this, this is x direction, this is y direction, and any nth direction at point A can be like this. That makes an angle theta with the horizontal axis, that is x axis. Theta is measured positive in counterclockwise from horizontal axis. Now if we call this point as n, then the direction AN, that is the direction making an angle theta in positive in the counterclockwise direction with respect to horizontal direction, is represented by this point n. Similarly, the direction AH might be represented by this point H, and direction AB can be represented by using this point V. So each point on Mohr's circle represents a particular direction passing through point A. So horizontal direction passing through point A is represented by this point, vertical direction passing through point A is represented by this point, and any other direction is represented by this point. The x coordinate of any point on Mohr's circle gives normal strain in the direction represented by that point on Mohr's circle. Now since each point on the Mohr's circle is representing a direction passing through point A, for example, direction AN is represented by this point N. Now due to the deformation of this element in x direction, we can see that this line AN has now moved to AN dash. So we can see that there is a strain in nth direction given by epsilon NN equal to AN dash minus AN divided by original length AN. Since this angle alpha is very small, we can assume that AN is along the same direction as AN dash for the purpose of calculating normal strain. Therefore, the strain along the nth direction, that is epsilon NN, is given by the x coordinate of this point N. Similarly, y coordinate of any point on Mohr's circle gives rotation of the line represented by that point on the Mohr's circle. This point N is representing the direction AN. Due to the loading, this body has deformed, because of which the direction AN has rotated by angle alpha to AN dash. The y coordinate of this point N gives the rotation of this line AN. That is, y coordinate of any point on Mohr's circle gives the rotation of the line represented by that point on Mohr's circle. So since this point N is representing direction AN, therefore its y coordinate will give the rotation of line AN, which is alpha, in this case in the clockwise direction. So x coordinate will give normal strain and y coordinate will give rotation of the line represented by that point. So for drawing Mohr's circle, on the horizontal axis mark normal strains. As we have seen, x is to be replaced by epsilon NN. Tensile normal strains are marked on the right side of the origin and compressive normal strains on left side of the origin. So if this is the horizontal axis with O as the origin, on the right side mark tensile strains and on the left side mark compressive strains. On vertical axis mark shear strains, as y coordinate is to be replaced by gamma nt by 2. Anticlockwise rotations of the line is marked below the origin. Consider two lines x and y at point A. Due to deformation, suppose this line AX has rotated in the anticlockwise direction like this. So this rotation of line is marked below the origin as it is anticlockwise rotation. Similarly, clockwise rotation of the line is marked above the origin. For example, consider this line AY. This line has moved to AY dash, that is, it has rotated in clockwise direction. So this clockwise rotation of this line is marked above the origin. So on the vertical axis, clockwise rotations are to be marked above the origin, and anti-clockwise rotations are to be marked below the origin. Now we have the coordinate for drawing Morse circle. Normal strains are marked on the x-axis and shear strains are marked on the y-axis. Now I will explain how to draw Morse circle from given strain element. At point A, strains are given along two perpendicular directions, that is, along horizontal direction epsilon xx, along vertical direction epsilon yy, and the shear strain between these two perpendicular lines is gamma xy. Using these three given values, we can draw Morse circle. The steps to be followed for drawing the Morse circle from these three given strains values are as follows. In step 1, label vertical direction as B and horizontal direction as H. Consider this element at point A. The x direction at point A is like this and y direction is like this. This point is to be named as H and this point is to be named as V. So AH is the horizontal line and AB is the vertical line. Now write down the coordinates of point B and point H. The element at point A, this is horizontal axis, vertical axis. Suppose the line AH has rotated due to deformation like this, and line AB has rotated due to deformation in the body like this. Then we can write the coordinates of point B as the first coordinate is the normal strain. Since point B is lying on the vertical line AB, therefore we will write the normal strain epsilon yy. The T with the normal strain indicates that it is an elongation. For the y coordinate, we write shear strains. This shear strain x and y is divided equally between these two lines as gamma xy by 2 and here also gamma xy by 2. Since this rotation of the line is in clockwise direction, therefore an arrow with shear strain indicates this rotation. Similarly, the coordinates of point H are normal strain epsilon xx because H is lying on the horizontal line, and the shear strain is gamma xy by 2 because the y coordinate shows the rotation of the line on which point H is lying. The rotation of this line is gamma xy by 2, which is in anti-clockwise direction. So this arrow indicates this direction. Therefore, the rotation arrow shown with the shear strains correspond to the rotation of the line on which points are lying. For example, point B is lying on line AB. It has rotated in clockwise direction as indicated by this arrow. And T or C indicates that normal strain is causing elongation or compression. Now we can mark these 2 points H and V on Morse coordinate. First we will mark point H. The x coordinate shows normal strain and y coordinate shows shear strain. Since it is tensile, therefore it is to be marked on the right side of the origin, as tensile strains are marked to the right side of the origin. So this is epsilon xx on the right side of the origin. The shear strain is trying to rotate the element in anti-clockwise direction. Therefore, it is to be marked below the origin, as anti-clockwise rotations are marked below the origin. So we mark gamma xy by 2. So This gives us point H. Similarly, the tensile normal strain is marked on the right side of the origin. In this case, we take epsilon xx is greater than epsilon yy. So we mark epsilon yy. Similarly, gamma xy by 2 is in the clockwise direction, so it has to be marked above the origin like this. This gives us point V. Now we can join point V and H like this, that intersects the horizontal axis at point C, which is the center of Morse circle. Now with CV or CH as the radius, we can draw Morse circle like this. So finally we have obtained Morse circle using the state of strain given at a point in two perpendicular directions, that is the horizontal direction and the vertical direction. Now there are certain points that should be noted about Morse circle. The angles of any line on a strain element are doubled when plotted on a Morse circle. Remember that we have eliminated variable 2 theta to obtain the equation of Morse circle from the analytical equations of epsilon nn, gamma and t. Consider this element at point A. This is the x direction, AH is horizontal and AB is the vertical direction. If the strains along AH and AV are given, then we can draw the Morse circle for the strain state at point A like this, where this point H represents horizontal direction and V represents vertical direction. Consider any nth direction at point A that makes an angle theta with the horizontal line AH positive in counterclockwise direction. To obtain the direction n on the Morse circle, we mark angle 2 theta from the horizontal direction in the anticlockwise direction. This point n represents the direction AN. Therefore, angles are doubled as compared to angles on the strain element. Now, principal strains are maximum and minimum normal strains at a point. It can be clearly seen that this point is representing the maximum normal strain epsilon 1 and this point is representing the minimum normal strain epsilon 2. The angle of principal direction is to be taken from horizontal direction like this. So this angle is 2 theta 1 and this angle is 2 theta 2. Maximum shear strain. It can clearly be seen that this point is representing the maximum shear strain as y coordinate gives gamma nt by 2. So this CV is giving gamma max by 2. Therefore we can say that it is the diameter of Morse circle gives maximum strain at a point. This ends this module.